Welcome back to our discussion of atoms. This will be the last section. And in this section, what we're going to do is we're going to talk a little bit more about converting moles and atoms and molecules, etc. So I mentioned earlier that Avogadro allowed us to go from the tiny world of the AMU to the real world that we live in of the gram. And so by saying that, what we've said is that the mass of a mole of atoms is the molar mass of that element. Okay, so it's the molar mass, and that molar mass is in grams per mole, and it's numerically equal to the AMUs. So if you have 12 AMUs, then in the world of the mole, then you're going to have 12 grams per mole. So this is because the Avogadro is 6.022 times 10 to the 23rd atoms per mole. And so that gives us grams per mole. And so this, like I said, allows us to do these calculations in real terms, not just AMUs. So the atomic mass is in AMUs, the molar mass is in grams. So 1 mole of anything, we said, is 6.022 times 10 to the 23rd, but it doesn't mean that it has the same mass. And how this is interesting is that for aluminum, for example, a mole of aluminum, which with the 6.022 times 10 to the 23rd atoms, is 26.98 grams of aluminum, whereas a mole of carbon is 12.01 grams, and a mole of helium is only 4 grams. So differences in the structure of these atoms gives us different numbers. And so that's why we must remember that we look at that mass number to find how many grams per mole is the molar mass. And so it's different for every single element. So there's 12 grams of carbon atoms in 1 mole. Okay, and so what again, that gives us another conversion where we can go from atoms to moles and moles to atoms. Now I'm going to introduce you to a little thing that I have developed called the Molehill, and students like to use this. It's just a visualization. So if you're a visual person, you know that if you have grams and you want to get to moles, you're going to use the molar mass, or we also, when we start doing molecules, we call it formula weight. So that's the same thing when we're just doing one thing as molar mass. So that's how we get back and forth between grams and moles. To get between atoms and moles, we use Avogadro's number, 6.022 times 10 to the 23rd atoms per mole. All right, and so a lot of people on tests, they just kind of visualize that, okay, and you got moles up, the Molehill is at the top, so go grams to moles and back and forth, or atoms, and just kind of help you remember what to do. The reason that this is going to be revealed later is because the top of the Molehill is when we start doing reactions and we have chemical equations, and so we go all the way over the Molehill when we start reacting materials together. So that's your tease for later in the semester. So let's apply this. Calculate the amount of carbon in moles contained in 0.0265 grams of pencil lead, and pencil lead is really carbon, okay? It's not lead. Even though we call it that, it's kind of a misnomer. Well, it is a misnomer. And so it's really just carbon. And, it's got different textures to it depending on if it's medium or hard or whatever. But the point is it's all carbon. So we have one thing that was measured, 0.0265 grams. So 0.0265 grams of carbon, because that's what the lead is actually. And I want to know how many moles that is. All right, so I know in my dimensional analysis I've got to get rid of grams. So when I'm going between grams and moles, I'm going to use the molar mass. And the molar mass of carbon is 12.01 grams per mole. So since grams goes with the 12, I've got to write it 12.01 grams in 1 mole of carbon. I get rid of the grams of carbon and I'm left with moles, which is what I want. And so I just have to do the math, and that is 0.00221 moles of carbon. And I'm going to use 3 significant figures because I had 3 significant figures in my measurement. Pretty easy. You just got to remember that you're using molar mass. Whenever you go from grams to moles, moles to grams, you use the molar mass of that specific element. Because if I was doing nitrogen, I'd be using around 14 grams per mole because that's the molar mass of nitrogen. So there's you a practice problem to do that with titanium. Titanium is Ti. All right, so now we're going to go mass to atoms, okay, because now I've got some conversion factors so that I can get all the way to there. So I start out with what I'm given, 3.1 grams of copper. Been a long time since since pennies were made of copper, believe me. All right, so 3.10 grams of copper. So I know I'm going to have grams of copper down there. And I know that I'm going to atoms of copper when I get done. So I've got to get rid of grams of copper. What do grams of copper and atoms of copper have in common? Moles. Okay, so I know 1 mole of copper, when I look on the periodic table, the molar mass of copper is 63.55, and if there are more decimals and you want to use them, that's fine. Okay, that gets rid of grams of copper in my dimensional analysis, and then I'm wanting to get to atoms, and I know, so it's going to have moles down there, and I know something that has moles and atoms in it, and that would be Avogadro's number. So I know in 1 mole of anything, and in 1 mole of copper as well, there are 6.022 times 10 to the 23rd atoms of copper. That allows me to get rid of that, and I'm going to be left with atoms of copper, which is what I want. So make sure you pause on this one and you are getting the same number that I do when you do this calculation. All right, and I get 2.94 times 10 to the 22nd atoms of copper for this one. Remember my EE trick with this so that you get it right. You're going to multiply 3.10 times 6.022 times 10 to the 23rd. It's tricky. And then once you get that, you're going to divide by the 63.55. And if you know how to do parentheses, I know you're doing that, and I don't care, okay? But you should get this answer. Remember on your exams, you're going to be showing me your work. So you've got to show me where this stuff comes from, because you're doing that instead of me watching you on video. All right? And then I give you plenty of practice on these because this is a critical concept and a critical skill that you need to know how to do this. Okay? All right. That's the end of the atoms chapter.